Hi guys, this is Elizabeth here. As you all know, we have left two topics uncovered in the chapter Hydrodynamics. So in this session, we will be discussing those topics which are the factors affecting surface tension and the applications of surface tension. So under factors, we will be discussing only those four which are mentioned in your text, and they are temperature, the presence of impurities, electrification and contamination. So let's begin with temperature. And for temperature, in short, as the temperature increases, the surface tension decreases. Why? Whenever we are heating up a liquid, the temperature of the liquid increases because the energy will be transferred to the liquid, which is reflected in many forms, out of which one is the average kinetic energy of the molecules. So if we are considering a liquid like water, the oxygen and hydrogen molecules are bonded by a covalent bond, which is a fairly stronger bond. So whenever we are giving temperature to the liquid, these molecules will try to get away from each other, breaking the bonds, and as a result, the cohesive attractive force between the molecule decreases and the surface tension as a whole for the liquid will decrease. So in the figure, you can see when the temperature is fairly lower, the cohesive attractive interaction is greater and the surface tension is also larger. And whenever we are providing temperature to the liquid, the molecules are trying to get apart each other, and as a result the surface tension decreases. So for a small temperature difference, or if you are increasing the temperature in a very smaller range, the variation of surface tension with temperature is linear, and it is given by this relation. The surface tension at any temperature T is equal to the surface tension at 0 degree into 1 minus alpha T, where alpha is the temperature coefficient of surface tension. Thus, if you are increasing the temperature in smaller range, the variation of surface tension with temperature is fairly linear, and as the temperature increases, the surface tension decreases with respect to this equation. Now, how does the addition of the impurities affect the surface tension of liquids? Depending upon the nature of impurity, surface tension can either increase or decrease. If you are adding a highly soluble impurity like salt, the surface tension increases. And if you are adding a sparingly soluble impurity like soap, the surface tension decreases. How is this happening? We will see now. So if you are adding NaCl, or a highly soluble impurity like the domestic salt we use in kitchen, we know that whenever we add salt into water, the salt gets dissolved. This is because the covalent bond in the water molecules are fairly stronger than the ionic bonds in the salt or NaCl. So the positively charged Na plus ions are attracted to the O minus ions, and the negatively charged chloride ions are attracted to the hydrogen ions in water. The water molecules pulls the Na and Cl ions apart due to its stronger covalent bond, breaking the ionic bond in the NaCl, and surrounds the Na and Cl ions, thereby dissolving the salt. Since the salt solution is more ionic, the attractive forces are more, and as a result, the surface tension of the salt water will be also more. If we are adding a sparingly soluble impurity like soap, soaps or detergents, they generally have a polar and non-polar part. The polar part will be attracted to the water molecules, while the non-polar part, which is hydrophobic, has a tendency to move away from water molecules, and they push themselves up to the surface. As a result, there is a weakening of the hydrogen bonds holding the water molecules together at the surface, and as a result of the attractive cohesive interaction between the water molecules, the surface tension of the water is reduced. The substances like soaps and detergents which can reduce the surface tension are called surfactants. Now we will discuss a simple experiment which each and every one of you can do at your homes. This experiment actually verifies what we have learned in theory, the variation of surface tension with soluble impurities. So in order to do this experiment, you need to have a dropper and a coin. First, fill the dropper with some filtered water and add drops of the water on the coin very carefully, one drop at a time, such that each drop has to fall a short distance before it merges with the drop on the coin. You have to keep a count on the number of drops accommodated on the surface of the coin till the liquid spills over the edges of the coin. Now repeat this experiment for the salt water as well as soap water and count the number of drops accumulated on the surface of the coin. What do you observe? We know that in case of salt water, the surface tension is very high compared to that of the fresh water, and as a result, the liquid drops tries to occupy the least surface area or a spherical surface, and hence a large number of drops can be accommodated on the coin. And in case of soap water, since soap water is having least surface tension out of these three, the liquid drops will try to spread over the surface of the coin, and hence the number of drops that can be accommodated on the coin will be very less. Thus, if we are considering these three types of liquid, salt water, soap water and fresh water, the number of drops that can be accommodated on the coin in case of salt water is much higher than in the case of soap water. Next is electrification. Electrification means the conduction of electricity through liquids. So whenever electricity is passed through a liquid, the bonds in the liquid gets broken, and as a result of the decrease in the attractive cohesive interaction, the surface tension decreases on electrification. Similarly, on contamination too, whenever if we are adding substances like oil or grease on liquids, we cannot say that it will reduce the surface tension because they do not get merged with the liquid. If we are adding oil or grease to the liquid, they actually form a very separate layer with a different surface tension. But at the oil liquid interface, the surface tension will be much smaller compared to the surface of the liquid initially before adding the oil. Thus, whenever we are adding oil or grease into liquids, the surface tension will be reduced at the oil liquid interface. Next, we will be discussing the applications of surface tension. First one is whenever detergents are added to water, it will reduce the surface tension and hence they can be used for cleaning purposes. So as you know, the detergents or soaps, they have a polar and a non-polar part. The polar part gets attracted to the water molecules, while the non-polar part, which is hydrophobic, has a tendency to get away from the water molecules, which will be attracted to the dirt molecules. So whenever we are adding soap or detergent to water, it will be reducing the surface tension of water, making it much wetter, and the water will be able to flow through the pores due to the decrease in the surface tension, and hence thereby helping in the cleaning purpose. Next, also we have already discussed, whenever there is an increase in the temperature, the surface tension of the liquid decreases, and hence the warm water is more efficient in washing clothes. Next is the property of surface tension to prevent water from passing through the pore of umbrella or a tent. This is because of a result of surface tension, which is the decreased surface area. So whenever the water molecule is having a surface tension, it will try to acquire the smallest surface area or a spherical shape. So it will spread less on a surface, and thereby it can be prevented from passing through the pore of umbrella or a tent. Similarly, due to the surface tension, the surfaces of liquid acts like a stretched membrane. Thus, the water striders or the water insects can easily glide over the surface of a liquid due to the surface tension of that liquid. That's all about the factors affecting surface tension and the applications of surface tension. Best wishes and thanks for listening.